So, let's see here. I guess I don't need this. Today we are talking about object-oriented programming. Does anyone know what that actually means? What is it? What is object-oriented programming? What does it do for us? Using objects to program. Nice. That is technically true. What does that mean, though? Why does it matter? Why do we use it? What are the benefits of object-oriented programming? It's a neater, more organized way of writing code. Sure, it can be. It definitely can be. It can help keep things less cluttered for sure. So what does it actually? It allows you to make objects to refer to and share. Sure. So what is an object? About to talk about object-oriented programming. What is an object? Everything in Python? Sure. Sure. But what is that? How do we define an object? Right? Just because everything in Python is an object doesn't mean we know what that is. An instance of a class? Sure. Yes. It would be the use of data types. Okay. So an object is a certain type of data. It is a data structure. So, and it can be definitely an instance of a class. It's usually an instance of a class. So, okay, if it's an instance of a class, then what is a class? An identifier, a collection of objects. Okay, not quite on either of those. Maybe if you can elaborate on identifier. A single definition. Okay. That is definitely closer. So what, a single definition for what? What is that actually? Can we elaborate on that a little bit? Oh, no, I just want what you guys know about objects and what you guys know about classes. There's no like concrete definition I'm going for necessarily. I'll give you my own. So the way I think about an object is a container for properties and methods. So it stores information, right? Stores certain information, and not just raw data information. It also stores the ability to perform actions. So a property would be, if I am an object, a property would be something that describes me, like my eye color or my hair color. That would be a property. And a method is just a function. It's just a function that belongs to an object or a class. A method will store some sort of thing that I can do. So one of those things might be speak, or say hello, or run, walk, things like that. Those would be methods. All right, so if an object is just a way to contain properties and methods, what might a class be? Something to hold objects? Not quite. We can hold objects in other data structures, though. We could hold objects in like lists or dictionaries, or a container of methods and objects. It can be a container of methods, not necessarily a container of objects. it's a way of making the objects. Yeah, that's definitely much closer to where we're headed. So that's partly true. It is a way that we can make objects, kind of, but it's not by definition how the actual object is created. By definition, a class is how an object is defined. It's like a blueprint. So if you have a house, or if you're building a like housing, I'm drawing a blank, housing development, right? If you're building a neighborhood, maybe you have 5 houses that you can build. Well, a class would define the blueprint for each of those specific houses. So one house would be one type of object, and a class would define all of its methods and properties that makes that house uniquely that house, as opposed to other houses. And whenever we want to make that house, we can just refer to that specific blueprint. So a class is a lot like a blueprint. It is a definition that we will use to create an object with certain methods and properties that are defined in the class. So, all right. Without further ado, let's start actually writing some code. I will go ahead and share my screen. Move this out of the way. All right, I'll share my screen. Where am I? I don't want to be there. All right. Cool. So here we are in our Python folder, our Python repository. Let me go ahead and make a OOP file. All right, so first, before we start, what kinds of things do we want to find? I will leave this open. I've traditionally done like humans, animals, things like that. And before we fully decide, we can do anything we want. We can define any class we want. But before we fully decide, I would like for this thing to be vague enough for something more specific to be defined. So for instance, if we were going to make a class a class called car, let's actually start with a class called vehicle, and then we'll do multiple classes that would be defined also by the vehicle class. So in other words, we would like to be able to inherit from a parent. So let's be as general as we need to be, but animals. Okay, 1 vote for animals. Anyone object to that? Cool. All right, so let's go ahead and start defining a class. Now, in order to define a class, it's relatively straightforward. We're going to use the keyword class. Not too bad. That's telling the Python interpreter that what we're looking at here is a class definition. All right, and let's go ahead and call it animal. All right, so notice it's a little bit different than a function definition. There's no parentheses. Not like this, but it can be. It can be, and if we do have parentheses, the argument we will pass through is another class. So for instance, oftentimes, if we want to just create an object that just is our own object that doesn't have anything to do with the data types that already exist in Python, what we would do is we would put object here. That way it gets all of the same sort of basic functionality of a Python object, which defines really base level stuff like the ability to access methods and properties in general. However, in Python 3, we don't need to do this. It will implicitly inherit from the base object class. So we don't need to do that unless we want to inherit from something else. Okay, cool. Let's go ahead and I'm going to activate my virtual environment very quickly. Do I have, where do I do it? First bin activate. That way I'll be able to run this later. All right, cool. So we have this class of animal. What kinds of properties would an animal have? And this is any animal. What are the things that define an animal? Number of limbs? Yeah, totally. Do tails count as limbs? Whether it's carnivorous? What kind of fur it has? So let's maybe back up a little bit, because not all animals have fur, and not all animals even, well, yeah, not all animals have fur. Not all animals even have limbs, as far as I bet they do. It depends on how you define a limb. We could do number of legs, but if we have number of limbs, we could say 0. I suppose we could say 1. Like a snake has 0 limbs. Maybe it's just one big limb. Who knows? Habitat definitely would be a good one. So let's figure out how to define these things. I definitely like number of limbs. I like habitat, and let's do diet. Okay. So in order to define properties inside a class, we're going to have to use this special method called the init method. Now, I'll show you what that looks like right now. Init. And every single method inside of a class always has to have self as the first parameter. Since this is a function definition, we can call it whatever we want. We could call it pizza or whatever, but what it's actually going to refer to is self, so we should call it that. I'm going to leave that there. We're going to talk about self sort of more toward the end of the class. We're also going to talk about what this init function does in just a moment, but for now, let's go ahead and say self.habitat equals something. Let's say, what is it? Tropical, rainforest. Self dot num limbs. What lives in a tropical rainforest? Who knows? Frogs? Cool. All right, so 4, I suppose. Self dot what else did we say? Diet. Bugs and stuff. Okay, cool. So we have this thing right now. If we wanted to, we can go make a new instance of this class, which basically means we will make an object that will use this class to create itself. So let's go see how that works. So my animal equals animal. All right, let's go ahead and print my animal. Let's see what happens. Okay, cool. So we have an animal instance at this memory location. That's not super helpful to us. This is kind of weird behavior that we've probably never seen before. An object, really, it's really similar to a dictionary, you guys. It's really similar to a dictionary. It just has key value pairs, right? We've determined what the keys are here: habitat, num, limbs, and diet. We've determined what the values for those things are here, but we can't see any of those things up front. So what I want to do right now is I want to convert this thing into a dictionary using this magic method, this magic double underscore term here. We refer to them sometimes as dunders. So this dunder method for double underscore. Let's go ahead and see what that is. And we can see it prints exactly like a dictionary now. So we can see exactly what's going on here. This is what our object looks like. I can make a bunch of animal objects, and they're all going to have these same basic things that we've defined here. Boom. Sweet. Well, this is cool, I suppose, but this isn't really very useful, right? Because we're just making frogs right now. We could give it a self.name. Cool. So this is fine, but all of our objects are going to be exactly the same. And that kind of defeats the purpose of object-oriented programming. I'm not redefining my animal as a dictionary. I'm just printing as a dictionary. Correct. Yeah. This doesn't change anything about the my animal object. It's just converting it into a dictionary just right here for the print statement. If I wanted to do print my animal afterwards, my animal is not changed. It's still, you can see an animal instance. Okay, cool. Yeah, thanks for that clarification. That is a very important point. So we don't want to just make Froggy the frog a bunch of times. It doesn't really make any sense. We could just do a dictionary that has this information, because if we're only going to be able to make one specific thing out of this class, then we might as well just make a dictionary literal and get on with our day. So the real power of object-oriented programming comes from being able to set various properties and methods that conform to the same, remember, kind of blueprint. So if we go back to the house example, we might have a house that's painted blue, and a house that's painted white, and a house that's painted green, that all conform to the same basic blueprint, right? It can do the same things. It has the same number of dishwashers and refrigerators, and it has the same number of rooms and bathrooms, but depending on the family, they might choose some different options for that thing. And we want to be able to build our class in such a way where we, as a developer or other developers on our team, can choose what those options are and create objects based on this same blueprint with individual information. So we want to be able to turn this thing into something that's more flexible. So in order to do that, we really have to dive into what this init function actually does. This init function, you'll notice the double underscores. That always means that this thing in Python is a magic method. We can look up in the Python documentation all sorts of stuff about all of the different magic methods. There are a ton, but it is magic because it does some certain things behind the scenes that are kind of important. These things are always kind of a big deal when you see them. But what this does is it is a method that is called only the first time you instantiate, or I guess I shouldn't say the first time, but when you create a new instance of this class. Meaning when we invoke this animal thing, we are creating a new instance and we're saving it inside this variable called myAnimal. We can see that happen right here. We can see where it's located in RAM. So when we do that, we will run this init function. All right. Now, before we can go making changes that are going to impact the rest of this, we need to understand what self is. Self is a reference to the individual object that is calling upon this method. So that's a little bit of a weird concept to understand. It might be a little bit easier to understand when we start defining other methods. So I will say name, or yeah, say name is fine. Remember that all methods have to take self as the first parameter. Let's go ahead and print self.name. Okay, so instead of printing this stuff now, let's go ahead and do myAnimal.sayName and invoke that thing. And we can see it is saying its name. Cool. It's just printing out the name. So what is self? Self, in this case, when this method is being called, self refers to my animal, the variable, or more specifically, the object, the animal object that is being stored inside the my animal variable. Okay, so if I wanted to do that down here with other animal, it wouldn't look any different because they both have the exact same name. So it might not make quite as much sense. But that's what it's doing. That's what self is. We'll explore this a lot more this class because it's a really important concept. Okay, let's see this comment here. Objects are sort of like a formula for creating something that will likely be repeated. Exactly. Exactly. So we create a set of data characteristics that can have the different animal parameters for each animal uniform. Yes, exactly true. So Paul is right on the nose here. Objects are exactly like a formula for creating something that will be used often. So if we only need one dictionary that is only going to be used once ever in our entire code base, we should probably just make that dictionary. But if we're going to have a million users and they're all going to look exactly the same, right? If they're all going to have the exact same properties and methods that we want them to have to be able to use our app, but for instance, they're all going to have different usernames and different passwords, things like that, we would create a user class so that we don't have to make a million independent dictionaries that all have the same methods and properties and stuff. So it really gets powerful when you only have a few things that you need to change. So some of the properties are typical that you would change, like the username, permission level, things like that. But you have a ton of methods that these things can perform that you want to make sure transfer over to all of the objects defined by that class. So it can become really, really powerful. And that's what makes it such an amazing technique for organizing your code. All right. So let's make this a little bit more flexible now. Let's give ourselves the ability to set these things independently for each object instance. So remember that this is a function definition. Python behind the scenes is going to implicitly pass self as the first parameter. Self being the object that is calling upon this method. In this case, when we invoke the animal function, this is the method that will be called, which means we will pass self implicitly as the first parameter. We don't have to worry about passing it here, obviously. Python will do that for us. We just need to know that it has to be there. All right, but we can accept other parameters because this is a function definition. So let's accept a name, a habitat, a number of limbs, and a diet. And let's go ahead and instead of just hard coding this information here, let's go ahead and take in and set the parameters that someone will pass in eventually. All right. Cool. So let's see here. When we want to create an animal that has some different name, and actually let's just try this because right now it will not work. We can see that init takes exactly 5 arguments and only 1 was given. The one that was given is the one that is implicitly given, self. We didn't put anything there, but yeah, I'm gonna keep driving that home because it's really an important concept. All right, so the name here, let's go ahead and make this one the same. Habitat. Number of limbs is gonna be 4. Diet is gonna be, diet is gonna be, cool. Sweet. And then our other animal is going to be, boom, cool. Sweet. All right, let's try this. So we have called upon my animal, and we've called upon the sayName method. That's pretty neat. Let's go ahead and call upon other animal dot sayName. And they're both printing different things. So we can use the same method and abstract out this information to be able to work for all instances of this class by using the self keyword and accessing properties of that class, using those properties defined in the individual object itself to do certain operations. Is everyone following all of this so far? Cool. Sweet. Good to hear. All right. Let's do some stuff. Let's create some other things. We don't have to take in our init function, we don't have to define things when we create the instance itself. Some things can be predefined. So for instance, self.health could be automatically hard-coded to 100. Maybe we just, when we create something, it's always 100. And maybe self.endurance is always like 0 or something. We could do something like that. All right, now let's go ahead and write some methods. So I want to write a method that will be for exercising. So I want our objects to be able to exercise. And what that's going to do is it's going to change the health of that animal to increase by 10. So I'm going to go ahead and pass self because that's always required. And how would I increase the health of one of our animals by 10 inside this function? Health equals health plus 10. All right, let's try it. So we're going to go ahead and do myAnimal.exercise. Do we need to pass any parameters to this function? So Adam and Jeremy are chiming in with self.health. So let's see what happens. Let's see what happens if we do just health. Ooh, local variable health reference before assignment. I really wanted to get to this error because many of you will see this many times. All right, so what are we doing here? Right here, we're saying, okay, on the left side of an equal sign, this is always the assignment piece. So we are assigning to the named variable called health this value on the right. All right, so we are assigning whatever is on the left to be this value on the right. So health may or may not already exist on the left, but we're only referencing the name of the variable. On the right, we're trying to access the value of the variable because we need to add 10 to it. We need to store the previous value of health plus 10 inside this new variable that we are assigning called health. Now, health didn't exist before this, so it is going to have no idea what to do with this. It's going to be like, we don't know what health is because health actually doesn't exist, but self.health does. Self.health exists, so you guys are totally right. Health should be a new variable, but it's not. There's nothing on the right side. It doesn't exist yet on the right side. So here we go. Cool. That presumably does something. But let's go see, how would we be able to verify that my animal's health has increased? How would we print that out? Print self.health in exercise. We could totally do that. All right, cool. So we can see that self.health is indeed 110 now. So that's a good sign. Now, how do we access properties from outside of the methods that we're using so that we don't have to use self? Well, remember, self is just a reference to this thing that's being stored inside this variable. So we could go ahead and print myAnimal.health, and that's going to accomplish the same thing. This is identical in a lot of ways to doing this, but we'll see that we have no way of accessing that property using bracket notation. And I mentioned this briefly the other day. So with dictionaries and arrays, we're going to use bracket notation to access values. But with Python objects, we're going to use dot notation. And we can see that we're using dot notation to access the methods as well. So we can go ahead and print myAnimal.health down here. We can let the function do its thing and then check that independently. All right, cool. All right, so let's go ahead and try something else. What if I wanted to exercise multiple times? What if I want to just keep exercising? All right, cool, and I want to exercise again. This is getting kind of annoying, having to type this out a bunch of times. I can copy and paste or duplicate this line a bunch of times. That's fine too, but this is kind of cumbersome right here. This is kind of cumbersome because I really want to exercise a bunch of times, but I just don't want to have to write it out in full every time. So does anyone know how we could get around that? We could loop for sure, but I still want to call the exercise. So you're absolutely right. All of you are 100% right, but that is not the answer. That is an unexpected answer for me. I don't know why. I should have expected that. That's not what I'm looking for. Although you really should loop. Anyway, okay. How about what if I wanted to exercise and say name in the same line? So instead of myAnimal.sayName, if I want to do a bunch of different methods with this animal, this particular object rather, how could I do that all in the same line instead of having to split it up into separate lines? So a loop will no longer work in this case, right? Self.help. So that's interesting. So we could take a parameter in exercise and we could do it a certain number of times. That's a great solution. That's absolutely a great solution. Also not what I'm looking for because exercise isn't the one. I just want to be able to do all of these things quicker. So let's do this. I want to be able to do this. This is called method chaining. All right. So right now I can't do this. It says none type object has no attribute, say name. All right, so we're going to talk about, I'm going to return self here. And then we're going to talk about what a return statement actually does. So does anyone know the few things that a return statement does? What does a return do? Does anyone know? It sends back some value, it ends the script, it returns a value to where it was called. So all of those things are exactly true. So first thing is that it will end the function wherever it is. So if we return self right here, neither of these two lines will run. It is the exact same thing as in JavaScript, as is the return in most languages. I can't think of one where it's different. So it will end the execution of the function and return to where that function was called. So if we go here, let's say myAnimal.printinfo. So if we're reading this code line by line, this is just all definitions. So we're going to read it, and we meaning the interpreter. The interpreter is going to read this thing, and it's going to read it line by line, but it's not actually going to run any of it until line 18. We're going to run line 18. We're going to return to here. We're going to run through this. We're going to go through here. We're going to go to the exercise function. We're going to end up returning, and then we are going to come back to literally this character, this spot, right? We're going to return to here. If there's anything else over here, it's going to just keep going. If there's not, it's just going to go to the next line and continue on. So when we call upon exercise, the interpreter is really going back up here to read through the exercise function and execute this code. So it's jumping around. So we jump to up here, and then we return to down here. All right, so that's one of the big things. The other really big thing is that it returns a value. So whoever, the few of you who said that, that's super important. What does that actually mean, though? When we return a value, it means that this thing right here, this statement, this function call, is actually returning. This function call is actually, like this whole statement can be interpreted as the value that is returned by the function itself. So in this case, what is self? Self is the instance that is being held onto by my animal, right? So self is basically the my animal variable. So when we return my animal, this whole of line 20 turns into just my animal. So we run this code, we do what we need to do, and then this whole thing, since my animal was returned, becomes my animal. So what that means is, if I return self, if all of this stuff over here has been turned into my animal, then this can be chained onto it because it's just my animal. So my animal.exercise is going to run this code and then return my animal, which turns this whole thing into my animal. Then we can do print info, which is going to return my animal, which means we could go do exercise again, and it's going to run from left to right. Now, it doesn't make a ton of sense to call the same method over and over again, but we might have 40 different methods defined in this class. We might want to do 10 of them per object in some function, and we want to be able to chain them all together so that we don't have to do 10 different lines. We can do just the one line. All right, is everyone understanding how this works in order? Okay. Yeah, so we can see that at this point in time, health was 110, and at this point in time, health is 140. So pretty cool. Okay, so chaining methods is a pretty big deal. Return statements are pretty important to know about. We've covered self. I think we are good to go to cover inheritance. All right, so what is inheritance? Why is that useful or important? If we call animal, what will happen? What is that? Animal where? What do you mean? Like dot animal like this? Is that what you're asking, Sarah? Animal is actually not a method in this class. It is the class itself. So the animal doesn't exist. You can see here, animal, well, I guess you wouldn't be able to tell. So animal doesn't exist. So we want to use the classes from animal to use in a new class. So are we back to inheritance now? So to answer, wait, let me answer Sarah's question. It will cause an error. It's gonna say animal instance has no attribute animal. Yeah, inheritance is a class that uses methods and potentially even properties from another class and extends that class, which is really helpful. So if we wanted to make, for instance, like a mammal class, and we want that class to inherit from animal. Well, now, by default, we're going to have all of the stuff that's defined inside animal for mammal. So let's go ahead and define our init function. Actually, let's not define an init function. Let's just do mammal. Let's see what happens. So let's go ahead and define, let's not even do anything. Let's just say pass. Let's try to make an animal, or a mammal right now. Mammal equals mammal. Let's see what happens. Actually, I can just do mammal print info. Okay, so check it out. Type error init takes exactly 5 arguments. So when we try to create this mammal, if we look here, this init function is inherited from animal. So assuming we don't need any other things inside here, assuming we don't need any other different properties, all of the init function has completely transferred over. And I promise you that the other methods here have transferred over as well. Now, if we really want to test that, we can go ahead and give this thing a name like Shamu water number of limbs. I don't know if fins count as limbs, so I'm just going to say 0 for now. Diet is small fish. All right, cool. Sweet. So we can see that we have basically just recreated an instance of this animal class, right? And we are using this print info method, which is, it exists on the animal class. We didn't specifically say that exists on mammal. That's what inheritance does for us. So if we want to get more specific about certain types of things, so for instance, let's go back to this housing example. If we want to say all of our houses have the same kind of front porch, because that's what makes our housing development company unique, we can say class house has a property of this front porch, and it has certain other methods. All of the houses do these things. And then from that class, we can inherit all those properties and methods to create each of our individual house types, which is pretty cool. So let's see how we can modify some of this information and add to it. If we want to create new properties at startup, which is probably true, let's go ahead and recreate the init method. And I just remembered that, okay, yeah, I may be confusing Python 2 and Python 3, so we're gonna try it. We'll see if it works. All right, so the init method is gonna need to take the same information, right? But in this case, we're gonna do something a little bit different. So it's gonna need to take name, habitat, num limbs, and diet, for sure. And then what we're gonna do is we are going to call the parent class. Super is literally just a reference to the parent class. So we are gonna call this parent class. We're gonna call its init method, right? Because animal has a method called init. We're gonna call its init method. We are going to run it using all of these bits of information here. All right, so name, habitat, num limbs, and food, diet. All right, cool. So we're gonna call it. So all of these things right here are in our function definition. These are gonna come from our constructor. And then we're gonna take those and directly just regurgitate them out back into this init method. So in this case, we are defining the init method. And in this case, we are calling upon the init method, okay? Calling upon the init method from the parent. So we're not defining anything. And after we call upon that and create this object, now we can add other things that we might want to create for mammals specifically. So self dot There are things that make mammals unique, but I don't know. Let's just do something generic like unique trait. Or actually, let's do something that mammals, let's do a trait that we can hard code. So hunger. Hunger is 0, so they're not hungry. Lungs, sure. Maybe they all have 2 lungs. I don't know if that's true. I'm not a biologist. Here we go. So let's try this thing. And super takes at least 1 argument. That's going to be a problem. I knew that I was going to mix up my Py2 and Py3 syntax here. All right, so we'll take an example from the platform. Actually, you know what? It might be worthwhile for me to just go through the Python 3 documentation, even though it is on the platform. Python 3, cool. Let's check it out. I want to look at the actual Python docs, so docs.python.org. This is version 3.1. It's not exactly what I want. All right, it's fine. Here we go. Cool, class objects, instance objects, method objects, inheritance. Okay. Let's go ahead and look for super. All right. .7 docs. All right. All right, now we're getting somewhere. We have super here. Super dot method arg. Interesting. I don't know why that's not working then. Should have args. Takes at least 1 argument, 0 given. I wonder if this is being run in Python 3. Let's try it. Python. There we go. Cool. So I was accidentally running this code in Python 2 for some reason. That's my bad. I need to go change some of my settings for my script runner. But now that I'm running it in Python 3, we're good to go. Cool. So this is how we use super in Python 3. We can see that we have all of the properties of the first parent class plus the hunger and lungs properties. And we can also add methods, but we can see that we also have access to all the methods. Mammal.printinfo, we never put that in the mammal class, right? But printinfo exists in the parent, and therefore we inherited all of the properties and methods required. So I think that's going to be about it for today. That's all we need to cover. So I'll open it up for questions. Has anyone started the OOP assignments? Or has anyone maybe been struggling with some of the assignments that they're currently working on that I can help with? All right. Well then, I will let everyone go a little bit early today. Remember that office hours are at 4 p.m. Pacific time, Monday through Thursday. I have regularly schedulable one-on-ones in 15-minute increments, and you can reach me via Mattermost or email. If you need anything, please don't hesitate to reach out. All right, I will see you guys next week. Look for an email coming your way. Check your junk folders tonight or tomorrow, maybe even both. All right, night everyone. You're welcome.